Okay. So if the question is to write the syntax directed definition for a simple type declaration and write annotated parse tree and the dependency graph for the declaration float a comma b comma c. Okay. So if this is the question, first what you have to do, you have to consider the grammar. Okay, step 1, we have to consider the grammar for simple type declaration. What is that? See, declaration is equals to type followed by, okay, l. So t type means it can be int or float, and local variables l1 comma id, because you can have more than one this variable declaration, right? So the grammar we have to consider this one, we have to remember. Okay, now construct the parse tree for the declaration float a comma b comma c, where a b c are here, it is identifiers, okay, represented by id1, id2 and id3, okay, along with partial annotated parse tree. Got it? Understood the question? Now there are three sub questions here. See, right? SDD and annotated parse tree and dependency graph. Dependency graph in the sense here they have a top-down approach, right? So dependency graph is the way this statement, okay, is parsed in the tree is called as dependency graph. Okay, we have to show the way order, okay, that we'll see. So now by using this grammar, we'll see first. See, first I'll construct the parse tree d tends to t l, okay, and l tends to l1 comma id. And how many variables are there here? Float a comma b comma c, right? Float a comma b comma c, three identifiers. So I have to consider this three times, l1 comma id. Now l1 at last it can be id, yes or no? So this I took now. This is ID1, ID2, ID3. Who will give the value for this ID? Lexical analyzer gives the value. ID1 dot entry, ID2 dot entry, ID3 dot entry. Okay. So now from where the execution start? Now the type is here, I'll consider float because the statement given is float abc, right? So now I'll associate the attributes to these non-terminal. Now t dot type is equals to float. See, I have transferred this one. Okay, so similarly we have to write the semantic rules also simultaneously. So now I'll write the semantic rules simultaneously, productions, and simultaneously write the semantic rule. Okay, what is the first production? D tends to TL. Okay, so for this what I am doing now, t dot type I am associating it into L. Okay, because I have to tell this data type. Okay, which is this data type. So I will transfer this to this one. See, this order what I am showing now. This is one. From float I have associated to t dot type, and then this is second one. I am associating float to L. As I am associating this float to its sibling, whenever the value is accessed by its sibling or to its parent, okay, sorry, to its uh, child, then it is called as inherited attribute. Okay, so as now this float value is associated to its sibling, this is an inherited attribute, so I am associating the attribute called inh, which it indicates inherited. Now the float is transferred to its sibling, so that sibling L becomes inherited attribute, so I have associated dot inh. I will give float. Understood till here? This is second position. Now from where it will be evaluated? Now I have to tell these identifier, three identifiers a comma b comma c, what we have is of type float. Okay, so one by one we'll see. So see, now the declaration passes through here, third part. Now as this declaration, that is L dot inherited attribute, what it is float, now I am passing to its children, child node. Yes or no? Whenever the value of an attribute is evaluated from its parent, okay, to the child, then it becomes inherited attribute. From its sibling or to the children, the variable becomes what, the attribute becomes what, inherited. So I'll give inherited. Okay, understood? So now again, this is third part. See, from here the value will be associated. See, now this id2 value what I have now, okay, see here, this id1 entry what I have, that I'll associate here. See, this is inherited because L dot inherited, what I have here I am associating to each, so it becomes inherited. This also becomes inherited. L dot inherited is associating to L1 dot inherited. Okay, this is third and this is fourth. Okay, then this is fifth. id entry, the lexicon analysis does an entry, and now we know that this is inherited attribute. Now I came to know that what it is associated, a, b and c, all these three are what type of attributes, inherited attributes, and is of type float. What I am getting to know here is these three variables are there, no, a b c are of type float. As the access is done from parent to its child, all these attribute becomes what, inherited attributes. Okay, this is sixth one. Got it? So this becomes, see, L dot type TL dot inherited. Got it? Next, production. Next I will write t tends to int. What happens here? T dot type integer is associated to t dot type. Then next, production, t dot float, where I have used just float, I am assigning it into t dot type. Next, L tends to L1 comma id. See, we have used two times this production. What happens in each time? See, I am passing from L dot inherited float to this children. So L dot inherited becomes L1 dot inherited in each case. So L dot inherited is equals to L1 dot inherited. Okay, then last, production, L tends to id. So whenever id is there, what we did, we just make an entry. Yes or no? So you have to use the function add type, because I am getting to know the type, right? From where? from L dot inherited. I am getting to know what the entry I am making for the ID is of type inherited. Whenever I know that it is inherited, it means that it is float from here. Yes or no? So I'll add the type. Okay. So this is the thing. So dependency graph is nothing but the same thing. The position, how it evaluates, we have to write it. Got it? So these are the semantic rules. Once again, I will draw the dependency graph from the beginning. Okay. Listen. See, D tends to T L. Right. First, what happens? I have float here. Now I made T dot type is equals to float. Before that, the lexical analysis make an entry now. Okay. See, L semi comma, sorry, comma ID. L comma ID. This I'll make as ID. So now this is ID1, ID2, ID3. So first lexical analysis make an entry. Okay, entry from 1. First one I'll make an entry here. Okay, next ID2 I make an entry here. Entry. Next ID3 entry. So I'll number this as 1, 2 and 3. Now as soon as I make an entry of the variables, so first I have to get the type of this. So now I'll get to know the type. So this is fourth one, I'll get to know the type. Next fourth one to I'll pass it to the sibling. So this becomes inherited, and it will come to know that these are variables which I am using is of type float. Okay, that I have to intimate. So now I'll get to know this is sixth part. I get to know that it is 4. So sixth to seventh I'll intimate its child node that it is inherited and it is of type float. So as it is we are inheriting, I'll get to know this is eighth one. Next ninth one I'm intimating this also, saying that this is of type float. Okay, so this is called as dependency graph, where I am showing the traversing, okay, of this tree. Got it? This is called as dependency graph. So if you write the semantic rule and this dependency graph, you'll get complete marks. Okay, hope you understood. Thank you.